So this will be hypothesis testing for the mean when the standard deviation is unknown. This comes from section 7.3. So remember, if the standard deviation is known, that's the z-scores. When the standard deviation is unknown, this becomes what we call the t-distribution. So t-distributions are a little bit different. So remember, the t-distributions have these what we call degrees of freedom. But in the end, we learned that t-distributions are just like normal distributions. So we can still use the concept of the normal curve when we do our thinking. So one thing's in hypothesis testing is we have to find this critical value. We have to determine whether or not to reject the null hypothesis or whether to fail to reject the null hypothesis based on the given information. So we need to find this critical value in doing this. So remember, to do this, we have this level of significance, which is we use the symbol alpha for that. Also, what's important is the degrees of freedom, which is going to be this n minus 1. To find the t values, we can use table 5 in appendix B. So again, to find table 5 in appendix B, if you go to your Blackboard, um, if I go to chapter 7 to start with here, just to get something opened up, it really doesn't matter what chapter you go in. Let's see if I can get this to load for us. Here we go. So if I hit the table of contents, we're in chapter 7 now. But if you go down to the very bottom of it there, you start to see dependencies. So with dependencies here, dependencies table B, table 5 is the t-distribution. So we have that kind of going on there. So it pulls that out there for us. Okay. So we can get this to kind of open up for us. Get this thing moved around a little bit. Get these things a little bit bigger for us to see. I think that should work. So the thing to pick up on in the t-distributions is we have these left tails, right tails, and two-tailed. Notice on two-tailed, we have to use half of alpha as well. So we have a couple things to take into effect with our table. So let's look at this first question. Find a critical value for a left tail test. So to find the critical value t sub 0 for a left tail test with the level of significance being 0.05 and n equals 21. Now to use our table though, we need to know the degrees of freedom, which is going to be n minus 1. So degrees of freedom is actually going to be this 20. So left tail means we're looking, here's 0. Left tail means we're looking to the left side. So t sub 0 is going to be about here. Alpha is going to be the area of the curve. So they're saying the area of the curve is going to be like 5%. This is going to be what we call the rejection region. So what we're trying to do now is just find this critical value that kind of gets us started on this rejection region. So if I'm using the table, we have this 0.05 with the degrees of freedom of 20. So we have a one tail and two tails. So 0.05 would be one tail. And we said degrees of freedom was 20. So that'd be like 1.725. So come over here, we're going to have then this, t sub 0 would be this 1.725. But notice how since it's left to 0, it's actually got to be a negative 1.725. So the table doesn't tell us whether it's positive or negative, but that would be the critical value t sub 0. So our rejection region is going to be left of t sub 0. If I look at another example, find the critical value for a right tail test. So right tail means here's 0. Right is going to be over in this area. So t sub 0 is going to be over here somewhere. So we're looking for this t value that goes along with this area of the curve, which is the level of significance, which is going to be the 0.01 or 1%. So our degrees of freedom would be actually 16. So again, if we use the table, we have 0.01 and degrees of freedom was 16. We end up with this 2.583. So T sub 0 would be 2.583. And notice that it is to the right of 0, so it would be positive. So to find the critical value for a two-tail test, we would have to have T sub 0 here and T sub 0 here. So if alpha equals 0.10, that's going to be, this area over here is going to be 0.05, and this area over here is going to be 0.05. So we'd have to split that apart. So in order to use your calculator, you just have to divide 0.10 by 2. So if I clear this off here, get that all off here, 0.10 divided by 2, that's how it does give me this 0.05. So my degrees of freedom would be one less than the sample size, so that would be 25. So if I'm using the table, so if I'm doing one tail, I have to do 0.05. Two tails, I could keep it as 0.10. So go down to 20, and you're going to see we'd have 1.725. 1.725. So we would have 1.72, actually it's 24. I don't think I did that right. No, sorry, degrees of freedom was 25. Make sure I did that right. Degrees of freedom was 25. So actually we would have 1.708. All right, so let's try that again. 1.708. So if we have 1.708 here, we have to have a negative 1.708 here. So that would be our rejection regions. If we're in these regions here, then we'd be rejecting the null hypothesis. Now, another thing we can do is you can use the calculator to identify these critical values. So one way to do it is if I hit the second button and hit the distribution, number 4, inverse t, is actually going to find us our critical values on the t distribution. So if I hit number 4, so if I have the area under the curve, it's going to be the level of significance. So for number 1, that's going to be 0.05. The degrees of freedom was 20. If I hit enter, we end up with this negative 1.725. So notice how this makes it a bit much bigger, so we can round it to the thousandths place and get this negative 1.725. So we get the same value there. Example 2, if I do that again, we have to use inverse t for the t distribution. This time our level of significance would be 0.10. I'm sorry, yeah, 0.01. It's just like 1%. Our degrees of freedom was actually 16. If we enter, notice we get this negative 2.583. So notice that the area in the curve here is actually going from the left. So we have to actually pay attention that since we're right-tailed, we have to actually use a positive critical value of 2.583. Here, if we do this last one, number 4, area, notice how we would just be doing the 0.05, we'd be doing the left tail. So we can't use the 0.10, we have to actually cut it into 2 pieces. So if I use the calculator, we actually have to use 0.05. The degrees of freedom would be 25. And that's how we did get this negative 1.708. So look, I got those actually backwards, didn't I? Sorry about that. Here's 0 in the middle. We know left of 0 is a negative and right of 0 is a positive. So I had those negatives backwards there, didn't I? So we actually could find these critical values by using inverse t on your calculator instead of using the table. Okay, so let's see what else we got here. So the next thing is we need to find this test statistic. we actually have to find whether or not we're in the rejection region or not. So to test the claim, we use this formula to find this t statistic. We have the sample mean minus the hypothesis mean divided by the standard error. So again, we're only going to use this if the standard deviation is not known for the population, or also they were saying like the hypothesis standard deviation as well. So to find this test statistic, t, what we're going to do is we have to know the sample mean minus they're saying the hypothesis mean, and divided by the standard error, which is going to be the sample standard deviation divided by the square root of the sample size. Remember, these conditions also have to be mentioned somewhere, that the population is normally distributed or the sample size is greater than equal to 30. And remember, the degrees of freedom is always going to be this n minus 1. So keep that in mind. So we're going to use this here in a little bit. So let's look at example 4. So what we're trying to do is figure out the hypothesis testing using a rejection region. So what we're trying to do is, reject or fail to reject the null hypothesis. So a used car dealer says the mean price of a used car sold is at least in the last 12 months is at least, so the mean price is going to be at least 21,000. So this kind of means greater than or equal to 21,000. You suspect this claim is incorrect and find that the random sample of 14 used cars sold in the last 12 months has a mean of 19,189. And you found out the standard deviation on yours was 2,950. So what they're asking, is there enough information to reject the dealer's claim at a level of significance of 5%? So assume the population is normally distributed. So if we look at this, we have normal distribution, so we know that's important to us. The other thing is we have to understand what our hypotheses are. So the null hypothesis and the alternative hypothesis. Remember, the null hypothesis is always the inequality one. So since we had up here is greater than equal to 21,000, the mean is going to be greater than equal to 21,000. And that's actually the claim as well. That's what the person's saying is true. So the alternative hypothesis is going to be the opposite of that. So it's going to be, the mean is going to be less than, I should have 21,000, less than 21,000. Okay. So remember, our curve is always on the inequality. So less than 21,000. So basically, we're going to be looking for a t-score over here, and this is going to be our rejection region. And we're going to have this 0.05 as our level of significance. So what we need to do is figure out, first off, what is our t value, our critical value, t sub 0. So to find t sub 0, we have to know the level of significance, which was the 0.05. And the degrees of freedom would be, since our sample size was 14, since n was 14, n minus 1 is going to be 13. So if I was using the table, I could find my sample statistic using the 0.05 and the 13. So if we do that, we have 0.05, one tail, 0.05, and 13. We're ended up with this 1.771. So our critical value is going to be this 1.771, but since it's to the left of 0, it's actually going to be a negative. So negative 1.771. Notice we also could have found that just using our calculator. We could have hit the second distribution, number 4. Area in the curve was 0.05. Yeah. And our degrees of freedom was actually 13. If we enter that in, notice how we get then this negative 1.771. So we can do it with the calculator or with the table. Calculator is probably more convenient. than the table. So I probably will start moving from there to just the calculator. So the next thing we have to do is find the t statistic and see where it falls with respect to our critical value. So to find t, we have the sample mean minus the hypothesis mean divided by the sample standard deviation divided by the square root of the sample size. So the sample mean was the 19,189. We're going to subtract the 21,000 was the hypothesis mean. And then we're going to divide that by this, the standard deviation was the 2950. And we're going to divide that by the square root of the sample size, which is this 14. So we pull that from the problem there. So let me slide this over here so I can kind of keep track of it. So let's clear this all off. So we have a fraction to start with. So alpha F1, number 1. So the 19,189, subtract the 21,000 goes on the top. And then we have the 2950. And we're dividing that by the square root of 14. If we hit enter, we get negative 2.297. So our t value is going to be this negative 2.297. So if we plot that over here, notice that the negative 2 point, our t value is going to be over here. Negative 2.2987 is going to be negative 2.97. Negative 2.97. Not that it really matters that much here. So we have negative 2.297. So notice how that would be in the rejection region. So we would be rejecting the null hypothesis, which means we're also going to be rejecting the claim, since that is our null hypothesis. So we would be rejecting the null hypothesis. And since the claim is the null hypothesis, we would say there's not enough information to support the claim. So we would be rejecting it. We would not be supporting it. Just can't verify it with what we got here. So there seems to be enough evidence here to reject and not support the claim. So if I look at example 5, what we can do is, see how many examples we got here. We got 2 more. Okay. So what I'm going to do is kind of, instead of using the t values, there's also what's called the p value. So the thing we have is if p is greater than the level of significance, this means we don't have enough evidence to reject the claim. So this would be fail to reject the null hypothesis. And then if the p-value is less than alpha, that puts us in the rejection region. So this means we would reject the null hypothesis. Now remember, the claim does not necessarily represent the null hypothesis. The claim could be one or the other. So it depends on where it falls with respect to the inequality. So if I look at this question here, an industrial company claims the pH level of the water in a nearby river is 6.8. So that's what they're going to be saying is the mean. So I'm going to make that here 6.8. Your analysts like 39 samples. So that's going to be your N. It's going to be 39 samples. And you measure the pH value of each. The sample mean is going to be 6.7. And the standard deviation would be the 0.35. So is there enough evidence to reject the claims company that alpha is going to be 0.05 at a level of significance of 0.05? Okay. So again, one thing we have to pick up on is since there was 39 samples, we can use that as our condition that this is going to be normally distributed, so we can use this curve. So the other thing is we have to pick up on what is our null hypothesis. Let's see here. Our null hypothesis and our alternative hypothesis. So notice how it says the pH level in a nearby water river is 6.8. That's what they claim. So they're saying the mean is equal to 6.8. So that's the claim. And then the alternative is going to be the complement of that, which is the opposite, which is going to be the mean cannot equal 6.8. So we have that going on here. So instead of trying to do the t-scores and things like that, we're just going to use what's called the p-value. So again, let's see where this takes us with respect to when we're going to use a calculator to do all this to find the p-value. So to find the p-value, what this is going to be is we're going to use what's called the t-test. So the test is going to be under stats. So if it's stats, go to test. Number 2 is t-test. So using the t-test, which is under the stat button, this can allow us to kind of sort through this. So we have stats is already highlighted, but the hypothesis mean was the 6.8. Sample was 6.7. The standard deviation was 0.35. And the sample size was 39. And notice how mu would be, we're always going to use the inequality here. So that's going to be the alternative, which is going to be that does not equal the 6.8. So if we come down here, oops, that didn't work, did it? So something happened. So hit stat again. Number 2, good there. 6.8, 0.35, all that looks good. Hit calculate. There you go. So notice how this gives us, if we did the t values, the test statistic would have been the negative 1.78. But what we're interested here is actually the p-value, which is the point. So the p-value is going to be this 0.08. So round to the hundredths place. So the question is, how does 0.08 compare to 0.05? So if we compare P to alpha, we have 0.08 compared to 0.05. Well, P is greater than alpha. Well, if it's greater than alpha, this means we fail to reject the null hypothesis. And notice that since our claim is actually the null hypothesis, this means we fail to reject the claim as well. So that kind of conclusion there on this. So we're feeling like their research is pretty accurate. We didn't see any discrepancies in that with our data. So let's look at example 6 here. So Department of Motor Vehicle Office claims that the mean wait time is less than 14 minutes. So the mean, they're saying, is less than 14 minutes. Less than 14 minutes. So as far as the null hypothesis, sorry, the null hypothesis and the alternative hypothesis, less than 14 falls under the alternative hypothesis. So U is going to be less than 14 is going to be that. And our null hypothesis is going to be the complement of that. So it's going to be greater than or equal to 14. It's got to be the other side of that. So we pick up on a few things off of that statement. So the next thing is a random sample is 10. So we're going to see if they're true or not. We're going to try to verify this. They're saying that the mean, when we did our sample, the mean wait time was 13 minutes. And the standard deviation when we did our sample was 3.5 minutes. And our alpha is going to be this 0.10. So again, what we pick up on is this less than 14 kind of means that we're going to be over here left is what we're kind of looking at. So we're trying to figure out, are we going to reject or are we going to fail to reject? So to do this, we can use our t-test to do this. So just hit stat and then slide over to test, and then number 2 is t-test. So if we change this out, our 14 goes here, our 13 goes there. Our standard deviation was 3.5. Our sample this time was 10. And this time we have a less than 14. So we do that. Hit enter, calculate. So that's how it gives us our p-value. Our p-value is going to be 0.19. So again, so how does p compare to alpha? So 0.19, how does that compare to 0.10? So that's how this is also greater than. So what this means is we fail to reject the null hypothesis. But notice our claim is actually the alternative. So if we don't reject this, we are rejecting their findings here. So we would actually be rejecting the claim. In other words, there's not enough evidence to support the claim. So remember, when we do the p-value, this is always with respect to the null hypothesis, but also our claim is actually the alternative hypothesis. So again, if we fail to reject the null hypothesis, that means we're actually supporting it. It means we're not supporting the alternative, which is actually where the claim is on that. So that's kind of where this takes us to on this. So see if that helps you out a little bit in working with this 7-3. Take care.